All right, so this video is going to cover two examples, well actually three examples, but for these two it's going to use a combination of derivative rules. We're still in section 2.4 using the chain rule. But for these two, we're going to use a combination of either the product rule and chain rule, or maybe the quotient rule and chain rule. So we're still in section 2.4, but these are just some more complicated examples. So I wrote down the product rule and the quotient rule. Okay, so I'll work out number 23. All right, so because it's x squared times and then x minus 2 to the 7th power, I'm going to be using the product rule. And so I'll be using this rule. So I got to let u and v be different things. So I'll use u as x squared, and then v is x minus 2 to the 7th. All right, so u is x squared. Derivative of x squared is 2x. So u prime is 2x, because that's 2 times x to the 2 minus 1 with the power rule, so it's going to be 2x. Now v is the x minus 2 to the 7th power. Now if I were to find this derivative, I have to apply chain rule. And in this case, it'll be the general power rule. All right, so that's going to be using general power rule. Again, it's just extension of the chain rule. So b prime, we drop down our outside function is raising something to the 7th power. So using the power rule, you drop down the 7, and it'll be that same quantity, in this case x minus 2, raised to the 7 minus 1 power. Right, so I'm first applying the n times u to the n minus 1 part, where u in this case is x minus 2. Well, then it'll be to the 6th power, it's because n minus 1, that's 7 minus 1. Then times the derivative of u, or the inside function. Our inside function is x minus 2, and the derivative of x minus 2 is 1, because derivative of x is 1. And then that'll be 1 plus 0, because the derivative of negative 2 is 0. So really it's times 1. Right, that's the derivative of x minus 2. So that's the u prime part, is what that is. So we know 1 times anything gives you the same quantity, so you can really just ignore the 1 and just leave it as 7 times x minus 2 to the 6th power. So that's what I'm going to do. I'm going to erase this 1 now. Okay, so now I just apply the power rule. All right, so I paused the video so I could write the power rule over again, but this way it's color coordinated to what we have. So u prime times v. U prime is 2x, so it'll be 2x times, and then v in this case is x minus 2 to the 7th. Then plus u times v prime. U is x squared. V prime is this 7 times x minus 2 to the 6th power. All right, so that's just direct substituting into the power rule formula. And again, to find v prime, I had to use the chain rule to get 7 times x minus 2 to the 6th power, which is really the general power rule for that. All right, so I have f prime of x. I'm going to use a different color. All right, so we can do some simplifying as far as, actually first I'll just go ahead and write it and then do some factoring. So this would be plus 7x squared and then x minus 2 to the 6. All right, I can do some factoring because these have x minus 2's and then they have the variable x. So I'm going to factor out x times x minus 2 to the 6th power. All right, so what that's going to give me for the first term is it'll be 2 times x minus 2. All right, that takes care of this one because I factored out x and then I factored out x minus 2 to the 6th, which leaves me with just x minus 2 to the 1st. So that takes care of that one. The second term, I factored out the x minus 2 to the 6th power, so that's gone. That's basically 1 times, and then I factor out x, so it'd be 1 times 7x, so it'd be plus 7x. All right, that's what it is factored. And then I would simplify what's in parentheses. All right, so x minus 2 to the 6, I just leave it as is because that's going to be really expand out to something really large. So ideally you want to keep it in its most simple format, factored format. So if I distribute 2, that makes 2x times minus 4, and then I can combine 2x with 7x to make 9x. And then 2 times minus 2 is minus 4. And then, so this is going to be the end result. Again, I used a combination of the product rule and chain rule. I had to use product rule because of the x squared times x minus 2 to the 7th is a product, and I let u be x squared. That means u prime was 2x, and I let v be the x minus 2 to the 7th piece, which I had to use a chain rule for that since it had an inside function of x minus 2. So by power rule, I drop down the 7, so it'd be 7 times whatever the quantity is raised to the 7 minus 1 times the derivative of the inside function. Our inside function is x minus 2, and the derivative of x is 1, and then it'd be 1 plus 0 because the negative 2 is a constant. So really that's just 7 times 1 is 7, so 7 times x minus 2 to the 6th power was what v prime was. After I found those, I plugged them in their corresponding spots in the formula. And then from there, I just factored out what they have in common, which was x minus 2 to the 6th. And then they also had the variable x. And then I did some simplifying after I factored that out with the stuff in parentheses on the right side. And then I got that to be 9x minus 4. All right, so that's that one. The next one. So 27, if you, I would write it, so it would be y equals x, and then instead of square root of x squared plus 1, I'm going to write that as x squared plus 1 to the 1/2. And there's two ways. You can use either the quotient rule or product rule. I'll first use the quotient rule. So I'm going to make a comment. So you can use quotient rule or product rule, and I'll show how you can apply the product rule after I first do it using the quotient rule. I'm going to pause the video and write down the quotient rule. All right, so I wrote down the quotient rule, and now it's a matter of identifying, again, T and B. T stands for top function, B stands for bottom function. In this case, T is going to be X, and then B is going to be the X squared plus 1 to the 1/2. So I'll write down T is equal to X. The derivative of X is 1, so T prime is 1. The bottom function is the X squared plus 1 raised to the 1/2. And for the derivative of this, I'm going to have to use chain rule. So the bottom function's derivative, b prime, using the general power rule. So I have the outside function is raising something to a 1/2 power. The inside function is x squared plus 1. So the derivative of raising something to the 1/2 power, you drop it 1/2 down, and it's going to be that quantity x squared plus 1 raised to the 1/2 minus 1, right? That's you subtract 1 from its exponent. Then I do the times the derivative of the inside function. And the derivative of x squared plus 1. So derivative of x squared is 2x. So it'd be 2x to the 2 minus 1. And then derivative of 1 is 0, so it'd be 2x plus 0, which is 2x. So the derivative of x squared plus 1 is 2x. All right, so again, I'm using the general power rule when I did this. In this case, u was x squared plus 1. So u prime was 2x. All right, that's what I applied. Well, then I could write this b prime one half times 2, those cancel out, so be x, and then be x times x squared plus 1, or yeah, x squared plus 1 raised to the negative 1/2 power. All right, I'm going to leave it like that for a second, and then I'll worry about the negative exponent when I plug it in. All right, so let me circle what I'll be plugging in. So this will be what I use for b prime. All right, so I divided out 1/2 with 2, so just left me with x. 1/2 minus 1 is negative 1/2, so that's why it's a negative 1/2 power. And then I'll plug this in for b, and then t is x, and then t prime is 1. So that's everything that I'm going to plug in. So y prime. So we have the bottom function times the derivative of the top function. The bottom function is x squared plus 1 to the 1/2. The derivative of the top function is 1. All right, so it's going to be minus, and then the top function times the derivative of the bottom function. Top function's x. And the bottom derivative is x times x squared plus 1 raised to the negative 1/2. right, that's in the numerator. The denominator is the bottom function squared. So it'd be x squared plus 1, the 1/2, and then I square that. Okay, so that's plugging everything in. I'm going to focus now on simplifying this. All right, let's see. So I'll put everything in terms of square root signs. So let's see. So I'll write this out. It's the square root of x squared plus 1. So that's just this part. And then minus x squared. And then that's x squared plus 1 to the negative 1/2. I want to make that positive 1/2. I put it in the denominator. So I have x squared up top. And then on the bottom is going to be the x squared plus 1 to the 1/2. All right, so that makes that negative exponent positive. But we know raising it to the 1/2 is the same thing as taking the square root. So I could write this as the square root of x squared plus 1 in the denominator. All right, and in this, I have 1/2 times 2, where these would divide or cancel out, so you just have x squared plus 1 on the denominator. All right, so right now we have y prime equal to the x squared plus 1, or square root of x squared plus 1, and then minus x squared over the square root of x squared plus 1. I'm going to combine the numerator into one fraction. So let me focus first on the numerator. All right, if I want to combine that into one fraction, now the square root of x squared plus 1, you could think of that as the square root of x squared plus 1 divided by 1. If I want them to have the same denominator, I need that the same denominator be the square root of x squared plus 1, since that's the denominator of the other fraction. So I'm going to multiply top and bottom by x squared plus 1, or the square root of x squared plus 1. All right, so what that gives me, so the square root times the square root cancels out the square root sign. So I would have x squared plus 1 from that part, and then minus, and then I have x squared. And they're both fractions are going to have the same denominator. So I'm going to go ahead and just write it as one fraction. And that one fraction is square root of x squared plus 1. And mind you, this is the numerator portion of the problem. Now I can go ahead and cancel out x squared with minus x squared. So you just have 1 over the square root of x squared plus 1. All right, that was simplifying the numerator into one single fraction. So all of this is what all of this is. So I have 1 over the square root of x squared plus 1 up top, and then divided by x squared plus 1. Now, I know in a previous video I said that if you have a fraction like a over b divided by c, you can go ahead and bring this x squared plus 1, this bottom part, up to the bottom part of the top fraction. So in other words, you could write it as the following. So I just brought the x squared plus 1 up to the denominator of the fraction up top. And you can do that when it's a fraction divided by some number or some quantity. Now, if I wanted to combine these, now the square root of x squared plus 1, that's the same thing as raising it to the 1/2 power. And to me, it's easier to write it like that, so that I know when I combine it with the other x squared plus 1, I'm going to add the exponents. Because this will be like x squared plus 1 raised to the first power. So you add 1.5 to get 3/2. And then that would be it. That would be the answer. Now keep in mind that is the same thing as this. So this is the same, it's just rewriting it further. So same result, just written differently. All right, so the complicated part was just after you applied the quotient rule, it's all the algebra involved to simplify the numerator into one single fraction. And so that's using the quotient rule. I'll show how you can also, if you don't like using the quotient rule, how you can apply the product rule for the same problem. So I'm going to rewrite the problem and then write the product rule. The same problem over again, but this time I'm going to show how to use the product rule. All right, so this is the product rule, and then this was the original problem. So if I want to apply the product rule, I need to rewrite the original problem into a format which I can apply the product rule. And the first thing we did in the other method was, well, raising something to the square root powers, or doing the square root of something is raising it to the 1/2. So this is really x, and then x squared plus 1 to the 1/2. And then to make it a product, I can bring this to the numerator and changing it to negative 1/2 power. So it'll be x times and then x squared plus 1 raised to the negative 1/2. And now I'm going to have a product. So u is going to be x. The derivative of x is 1. So u prime is 1. V is going to be the x squared plus 1 raised to negative 1/2 power. So v prime, if I take the derivative of this, I'm using the power rule, general power rule, which is really chain rule. So the first thing I do is the outside function is raising something to a negative 1/2 power. That's the operation of raising quantity to the negative 1/2 is the outside function. So the derivative of that, you drop down the exponent, so it'd be negative 1/2. And then you just write the original inside function over again. So x squared plus 1 raised to the negative 1/2 minus 1. All right, that's the power rule part. Then I multiply it by the derivative of the inside function. So the derivative of x squared plus 1 is 2x. Because derivative of x squared is 2x, and then plus 0 would be because of the 1's a constant, so it would be 2x plus 0, which is 2x. Again, that's the derivative of the inside function. All right, so then I can do -1/2 times 2 to get those 2's to cancel. So I have -x. And then I have x squared plus 1. And then I do -1/2 minus 1. Well, that's -3/2. All right, so that's what the v prime part is. So I'll circle that. That's what I'm going to use. And then I'll use this for v. And u is x and u prime's 1. So I guess if you don't like negative exponents, this is a route that you might want to just stick with doing the quotient rule. All right, so y prime so it'd be u prime, which is 1, times v and then plus u, which is x, and then times v prime, which is this whole thing, -x times x squared plus 1 raised to the -3/2. All right, so now it's a matter of simplifying this. All right, and this is where some algebra steps are going to be a little complicated. So I'm going to have y prime equal to, and if I were to factor, these both have x squared plus 1s. Now, one of them has -1/2 power, the other one has -3/2 power. What you want to do is factor out the one that's the most negative. So what I'm going to factor out is x squared plus 1 raised to the -3/2. Now we know for the second piece, that's just going to leave me with -x squared. Now the first piece, how do I factor that out from x to the -1/2? So that's where it involves knowledge of exponents. So we know for exponents, if you have the same base, different exponents, you multiply them together, you get a to the m plus n. And I kind of am going into the reverse, like I want to factor out x. Factor out x squared plus 1 to the -3/2 from x squared plus 1 to the -1/2. Well, what you do is you multiply them together. Hold on a second. All right, so I paused the video, realized I messed up. You don't use this rule because when you're factoring out, you're actually dividing. I got it confused with multiplication. So we're really using this, what's in red. You divide out whatever factor you're factoring out. And in this case, the factor that I'm factoring out was x squared plus 1 to the -3/2. So that's what I divide by. So I have x squared plus 1 to the -1/2 divided by x squared plus 1 raised to the -3/2. And now I use this rule. And so that becomes x squared plus 1, and then the exponent is -1/2 minus a -3/2, which we know a negative and a negative makes that to be positive. So that's really -1/2 plus 3/2. Well, that's really 2 over 2, right? 3 halves minus a half is 2 over 2, which is to the first power. So this is really x squared plus 1 to the 2 over 2, which is the same thing as x squared plus 1 to the first power. All right, that is the result of when I factor out x squared plus 1 to the negative 3 halves. All right, so again, I factored out this x squared plus 1 is what they have in common. We factor out the one that has the most negative exponent, negative 3 halves. It's technically supposed to be a smaller number than negative 1/2 since it's more negative. So you factor out the one that has the lowest exponent in this case, and it's actually negative 3 halves. So if I factor that out, then I divide out x squared plus 1 to the negative 3 halves from each piece. Now the second piece is easy because you're just taking it out, so that gives you just x squared or minus x squared. It was the first piece where I figured out, okay, what does that become? And that became x squared plus 1 technically to the first power after I factored out x squared plus 1 to the negative 3 halves from x squared plus 1 to the negative 1/2. I just did it incorrectly at the first. So this was not the correct way. I should have done division instead of the multiplication. So again, this I'm dividing the x squared plus 1, the negative 3 halves. That's what goes in the denominators, what I'm dividing out. And that was all this using exponent rules turns into x squared plus 1 to the first power. All right, so that was just steps to get to that. And then I have plus, or actually minus x squared. All right, so the second piece was I factored this out entirely, so that just left me with x and x to make x squared. All right, so then focusing inside of the parentheses, you have y prime, and then I'll worry about the negative 3 halves in a second, just focusing on the parentheses right now. All right, so I have x squared plus 1 in the first power is just x squared plus 1. And I have a x squared and a minus x squared. Those cancel each other out. So I really just have times 1. And now that that's negative 3 halves, I put it to the denominator. So it becomes positive 3 halves, and then I have 1 in the numerator. So that would be, should be the same answer as what I had using quotient rule. All right, and it came out to be the same answer, right? Those are the same. And this is the steps right here. It was really, you want to just ignore this part. And then to get what's in red, x squared plus 1 of the first power, this is like scratch work. And really all I did was I took the factor out of x squared plus 1 to the negative 1/2. So I just divided this by this. Okay, so that's it for this problem. And there is one more problem I need to do, and I think I'll save that for another video.